Concrete block are a relatively new building material, with builders first experimenting with block production in the mid-1800s. The first U.S. patent was given to C.S. Hutchinson on March 6, 1866, for a hollow block. Block was developed and used as a result of skyrocketing costs of lumber and brick. In the early years, the hand tamping machines were taken to the job sites and the block were produced there. Materials were inexpensive, and the only cost to produce a block was the cost of the machine, which in 1906 sold for about $100 each. As a result of the large number of backyard and basement producers and no testing of their materials or quality assurance during the infancy of the industry, concrete blocks struggled to gain acceptance with masons, architects, and engineers. Through the efforts of many pioneers, as well as the formation of the National Concrete Masonry Association, the industry gradually gained acceptance through testing and quality assurances. With time, backyard and basement producers were slowly replaced by production plants with technology and automation that could mass-produce block with tight tolerances. These plants could produce thousands of high-quality units in a day, whereas the hand-operated machines were only able to produce 8 to 10 blocks per hour. Within the state of Kansas, a group of producers formed the Kansas Masonry Industries Council, or KMIC, in 1952. Salina Concrete was a charter member of this group, and in 1952 there were 27 block plants operating within the state of Kansas. These plants were scattered throughout the state, operating within close proximity to areas of high population. Plants were found in cities such as Lawrence, Garden City, Clay Center, and Junction City. In 1952, Topeka had 3 operating plants. Through years of competition and the development of technologies allowing for mass production, concrete block production facilities were consolidated throughout the state and country. Of the 27 plants operating in 1952, only 5 continue operating within the state of Kansas in 2013, one of which is Salina Concrete. Salina Concrete added concrete block to the production mix in 1938. A Stearns machine was first used in Salina and made 900 blocks per day. In 1952, a Besser 1948 B3R was installed and replaced the old Stearns machine. Salina Concrete purchased the machine through a royalty program and paid a penny per block made to Besser. Salina Concrete paid a machine operator an hourly wage with a bonus of a penny per block once the quota was achieved. With the Besser, Salina Concrete could now produce 4,000 blocks a day. Production capabilities continued to increase with the addition of a new loader and unloader system installed in 1966. This plant configuration was run until 2001, when another Besser V312 was installed and is still in operation today. The current plant can now produce 7,000 blocks in a day. Salina Concrete still produces concrete block daily in the production facility that originally was built for silo stave production in 1913. The product mix consists of load-bearing masonry units, landscaping products, which are available in virtually every color of the rainbow. Block produced in this plant can be found in homes, schools, banks, churches, and thousands of other facilities throughout the state. 2 local examples are Salina Central High School, constructed in 1952, and Salina South High School, constructed in 1971. The Salina Concrete sales and production personnel work tirelessly to provide a high-quality product which customers have affirmed to be true for decades. To understand how a block is produced, you will see here in the video, aggregates such as sand and haydite are delivered and deposited into the pit at the base of the elevator. Through the use of gravity and vibrators, these materials are moved down the pit to the mouth of the bucket elevator, which takes the aggregates 1 bucket at a time overhead and deposits them in the appointed silo. Cement is delivered and stored in the same way as is done with the ready-mix department, through pneumatic trailers and blown into overhead storage with the Cyclonair system. Once all the materials are in place, the computerized system will then batch appropriate volumes of aggregate, water, cement, admixtures, and colors into the mixer. As is the case with the ready mix batching, this is a computer-controlled system ensuring the highest quality control during production. After the mixer has adequately mixed the materials together, the zero slump concrete is dumped into a bucket, which is then elevated to the top of the block machine and dumped into the hopper. The machine then, through the use of cams and extreme vibration, shakes the material into the feed box, which is in turn compacted into the mold box, providing the structure for the concrete shape being produced. The machine will cycle, producing 3 8x8x16 units at the rate of 5 to 6 cycles per minute, or 15 to 18 blocks are produced per minute during a typical production day. The units that come forth are essentially sand castles, in that they are very fragile and can be easily broken when minimal hand pressure is applied. These units are then put into kilns for curing. The curing process uses heat and steam, with temperatures reaching 160 degrees for extended periods of time. This process accelerates the curing process, and within 24 hours, the units that were sandcastles are now rock-hard masonry units. These blocks, when tested at 28 days, typically have PSI strengths exceeding 3,000 PSI. Technology has added greatly to the performance and aesthetics of concrete block. Concrete block, which were developed at the turn of the century, were only available in a gray color and a smooth surface. These units were structurally sound, but were unable to prevent moisture from penetrating them without a good painted surface. Today, concrete block, while still structurally sound, are available in almost every color of the rainbow and have multiple textures such as rock-faced or scored appearances. Additionally, through the use of admixtures, these block can become a watertight unit, preventing water from penetrating the surface of the unit.